Okay, so I'm gonna record that from the beginning because I don't have my mic on. There we go. That's weird. That's like that, but okay. Okay, that's how that works. Let's start from the top. Hey everyone, I'm okay. Hey everyone, I'm Cello. Why am I talking like a roll? Just talk like myself. Okay. Hey everyone, I'm Cello, and today I will be learning how to do ray tracing in C++. Mainly because I'm bored, and because I don't really have much on my CV, my project list, whatever, and I'm going into my final semester with no internship. Maybe. That's how it's most likely gonna be because, it's August, almost the end of August. It's like August 19th, and there's only like a week or two, maybe 3 weeks left until school starts. So, unless I really, really get through the application process, I don't get an internship. Okay, all that aside, let's see if this is gonna be something simple or something torturous. But yeah, welcome to this weird journey that I'm gonna be on for a bit. So I'm gonna be live streaming this. I'm probably gonna do this for a lot of videos where I just live stream and then have it in the video. So yeah, if you'd like to, I don't know, that seems like too long of an intro, but I could always edit this later. But if you'd like to come join the live stream, no set schedule, but I'll probably be live when I post something. But yeah, now we start. That was cringe as fuck. So yeah, I'm just gonna be using the Code Crafters tutorial, kind of. I kind of have an idea of ray tracing, but I don't really have a set idea. So we're just gonna be, this is gonna be boring, but we're just gonna be going through this and learning. Where am I saving this video? Because this might be a big file. I never checked it, did I? Okay, saving in my hard drive. I'm chilling. Okay. I've already read a bit of this, but how does it work? Scratch pixels tailored for beginners. Perfectly suited for melee. Can be interesting. CGI. Blah blah. The only reason I'm saying blah blah is because I have already read that. Lessons offers a comprehensive introduction to the realm of 3D computer graphics programming, key rendering, ray tracing. How they're gonna be delved into the 3D graphics. I'll probably watch videos as well. Let me put on some music. Sure. I'm on this very same account, but sure. Animation, simulation, image processing, and more detail. We will learn about alternate techniques. Low key, that sucks. That sucks for music. You know what? I have. Is there something I can put on for you guys that I could just leave it without music? To be honest, just use my own. I know that sounds weird, but I low-key need music. Let's not have that up. Oh, this is a weird setup, having that in my ear. Feels like it's gonna fall off. Yeah, no, that's not gonna work. I'm just gonna have to do copyright-free music for sure. Let me just undo that then. Not that one. I guess. I don't know. I guess. Not exactly how I want to do it, but I'm gonna lower it a bit. I'm hoping while recording this, the quality of the recording is good. But yeah, comprehensive drugs, blah blah blah, rendering, delve into the world of 3D graphics in the context of graphics programming. To begin by grasping how three-dimensional scenes are transported to two-dimensional graphics. Yeah, this is more of like a prelude. Delve into deep ray tracing. I can also just watch videos as well. I'm not trying to follow this to a T. Obviously, want to do random things as well. But I'm just gonna be using this to start, and then I'm gonna figure out a project and do something like that, some like mini project. Should be recommended lesson overview of ray tracing rendering techniques for more focused explanation. Provide with you practical program that you can compile and execute and ignite into engaging with hands-on projects. Thing is, I am very much skimming through this. Natural phenomena, occasionally in reverse order through suppressing nature's complexity does not diminish the enjoyment derived from the universe. How the image created, line of sight, vantage point, canvas. I actually don't know how this looks for you guys, but I'm hoping it's decent. There's no one here. How was an image created? Line of sight, canvas. I'm pretty sure it's from my knowledge of ray tracing, it's essentially, I don't know if it's from the source here, but we essentially, I guess we would have like a light source. We would have light ray tracing, like that's exactly what we'd have it. Look, it's a lot of computing, but you send the like rays of light onto the object and then have, I can't remember if it's, you have it so that once it hits the object, that's what's actually showing the object. I think that's what it is. So it's only showing what it's reflecting off of, and it's just like a bunch of math, a bunch of calculations. A cut made through a pyramid, its apex located center, it was medium for projection. Okay, I'm gonna be swapping between like my energy drink, my water as well, since I hate the taste. Should I have the timer? I think I have. What is it called again? I recently installed it. It's not on here. It's fine. Through a pyramid with the apex position, the viewer's eye extending in the direction of the line of sight. This control slice is determined in the image plane, akin to canvas for artists. Image creation, processing across various mediums for film or digital sensors and cameras. The traditional canvas for painters. I feel like I'm moving my mouth to the left so much. Perspective projection is a technique that translates three-dimensional objects onto a two-dimensional plane, creating the illusion of depth and space on a flat surface. Imagine wanting to depict a cube on a blank canvas. This wrong lines from each corner of the cube, where each line intersects the image plane. A flat surface akin, blah, blah, blah. Marks made. For instance, if a cube corner labeled C0 connects to corners C1, C2, 3 on the canvas, results in a C0, C1, C lines drawn in between projections. Yeah, on the canvas over the cube's edges. Okay. Onto a canvas. Two-dimensional depiction of the cube. This method, known as perspective, was mastered by painters. So, low-key, this is kind of a lot for my. I'm like, I don't know. I hate reading, to this extent. I know it's a good thing to have, though. Running process, transforming a three-dimensional scene into image unfolds into two primary steps. Initially, project the contours of three-dimensional objects onto a two-dimensional plane on the image surface. I'm barely reading this. Light, material, photon, electron. Yeah, I guess you would need to know this, but like this is low-key boring. I don't know. I hate that stuff like this is boring to me. Like just reading it. But I guess you do need to know how it works. Okay. Work sheds light on the fundamental principles behind our ability to see objects. From his studies, two key observations emerge. First, without light, visibility is null, and second, without objects. Are you paying attention now? Oh fuck, I pressed the wrong one. I meant to do this. I have a separate webcam. You paying attention now? I did not read any of that. In scenarios such as traveling through intergalactic space, where the absence of matter results in nothing but darkness, sick, forward tracing, countless lasers hit the green sphere, will reach the surface of the eye. An object is crucial to understand another physical concept of the mirror and ways to fix off an object like skill factor can actually be perceived with the human eye for its skin and elsewhere to medicine for fun of time. Maybe this is too big of a scope, but fuck it. I've committed. It travels potentially land until it encounters object surfaces, assuming no absorptions. The photon is then reflected into a seemingly random direction. If this photon reaches our eyes, we discern point. Thing is, I already kind of understand how it works. I watched like a video months, maybe years ago. I can't remember. And it was like literally explaining all of this. So this is kind of boring. Like, let me see if I can find it. Hold on. That's literally what I searched to. Let me see what that is. Is it Tech Quickie? I can't. There was a video I watched. It's not this. It's not. What was it? Computer file? No. Why is it up? Not what I meant to do.
Thanks for watching.
I will watch that video in a second. Well, it might have been this video. I can't tell. I think it could have been this video. No, it's just an ad. I can't find it. I'm gonna watch this video in a second because low key I am pretty bored. But it's only been like 10 minutes. I haven't even started programming yet. Honestly, if I can just skip all this and just start. Yeah, this is unbelievably boring, but first download source code to your local machine, C++ compilers such as Clang. Okay. But this isn't what I wanted at all. I didn't want a lesson on like, I'm so confused. Okay. So it gave me a few things. Traditional cursor retracing of president pseudocode. Okay, but what do I need? Do I need anything specific? Fresno's object info. This is why I hate watching stuff. Or sorry, I hate reading stuff, because like I have no fucking clue what I need to include. Okay, that taught me nothing. So do I'm confused. Okay. It wasn't really shown much. Explained how it works. Wrote the pseudocode. Okay. Where is it? Where is it? It was a 3D render. Would this be what I want? Holy shit, this is a lot. Okay, this looks like I can do it. I look, you haven't read this, but let's just start with this. Oh, that's not what I meant to do. Whoops. To restart a renderer, you need a way to see an image. The most straightforward way is to write it to a file. Okay, let's launch VS Code then, finally. Yeah, this was just me doing some random stuff in Rust. Let me do this on another screen so I just don't have everything out and about. Where's my dev folder? Code. Now let's do this. New folder. Ray tracing. Don't want to use AI for this, so I'll just do this. Not what I meant to do. Why do I not have split windows? Huh? Why is my... Okay. What is my computer doing? Fucking awesome. What the fuck is my computer doing? Genuinely. Like, why did it just stop working? There we go. Why do I have to do that? I've never had to do that before. Okay. main.cc. Why are they calling it? I'm just gonna call it main.cpp. Oh. Interesting that that's what that does, but okay. Include. Haven't done this in forever. I'll stream. Expected a file name. Okay. Main. So for the image width 256 by 256. Okay, fair enough. Int if I could type, and then rendering it standard See out. Normally what I would do, because I'm a bit lazy, is I would do this using namespace std, and but I'm too lazy, and apparently it's not good practice. I found that out years ago, but I'm trying to actually not have bad practices, so let's try this how you're supposed to be doing it, apparently. Even though I think it makes the code look way cleaner. Did I spell image wrong? No, that's correct. It's just error linting, or whatever it's called. Is anyone watching? Question mark. 255 / and then the for loop, if I can type. Inch J. Why are you starting off with J instead of I? Weird. Okay. Image height. G++. I actually kind of miss doing that for. The fact that this is backwards is weird to me, because I would have done IJ instead of JI back in the day. I think that's still the case. So, whoops. I still don't know why that's the case here, but it is what it is. I is image width. I'm gonna fix that in a second. That is bugging me as well. I++. How am I haven't programmed properly in a while. I'm getting cramps. This is, I don't know. I mean, I've programmed this. I don't know why I'm cramping right now. Auto R equals double. This, actually, hold on. Before I do that, because I don't want to do it with, I forget. Auto in C++. I think just auto assigns it, right? Text type, yeah. Just want to double check. Double I divided by the image width minus 1, not height. Auto. Okay, RGB. Okay. Double J divided by image height. If I can type. I'm all over the place right now. Image height minus 1. No, I think I'm just trying to rush too much. Let me take my time, even if I am slow. And then auto B is just equal to 0.0. And then int IR is equal to. Interesting. Why is this? Maybe they explain it later or above times R. And then lucky this would be the one time I would enable the autocomplete for Copilot, just because my hands getting fucking tired, but 255.999 times G. I'm just gonna do this. This was quicker. I don't know why I didn't do this earlier. And then standard semicolon cout IR. IG. There has to be an easier way to do that, by the way, than just this. IB. /n. Also, instead of /n, we could have just done &l. No? Yeah, I think we could have. What's wrong here? Expected a semicolon. Where? Where did you expect a semicolon? Huh? No, this is correct. I'm confused. Where is it? Oh, here. Okay, that's saved. Then I could run. Let's do this. So is it gonna run? Java activating. Oh, I see. Okay. So this just outputted the RGB. Okay. Okay, I see. Stored in a PPM format, new line character and each line. So this is what this would be. In rows, every row is going out the laser or net. Each of the red green components represented internally by real value variables. From fully off to black. Blah blah, adding red and green light to make yellow. Outstream is redirected to an image file to be done from the command line by using the redirection operator on Windows. You'll get the debug build from CMake running this command. The thing is, I made this, but I didn't use CMake. I should have used CMake. Not really clear. Let me do C. I don't even know if I have CMake installed, but I hope I do. -b build. Fuck. I have the installation installed, don't I though? CMake. I do have installed. Okay, maybe let me try running it differently, because I think I fucked up by doing it that way. Okay, so I ran it with CMake clearly, but is it running infinitely? I think it is. Okay, so it does work. Oh. I'm lazy, but can I just do this? No. Fuck, how do I make a CMake? Why am I forgetting how to do this? I'm sorry for anyone that is watching me just absolutely fail at this right now. I really don't remember what the fuck I'm doing, to be honest. And it's kind of cringy, so I apologize. I actually can't believe I fucking forgot how to do CMake. I know you need to make the list, right? Ah, that's all I have to do. CMake or make dir build. CD build CMake dot dot. Okay, so I have to. I should have just used fucking GCC or some shit, bro. Fuck CMake. Is it not touch? I swear you could have. Bro, what? Okay. And then. Let's just do this. I don't know. I'm just gonna call it ray tracing. And then. Executable. Ray tracing main.cpp. Low-key, I should probably delete the VS Code stuff, but I'll do that. CD build CMake dot dot. There we go. Okay. Now we actually have build files. Do I need to be in the folder? Just go up, see if this works. Dash B build. CMake dash dash build. Okay. Yeah, I think I have two conflicting files now, but and CD to build, I think, and then image.ppm. Oh, not to pipe it. I probably could have done that normally as well then. Or redirect it, sorry, not pipe it. Where the fuck is it though? It's in debug. So here's the XC. Okay, I don't want to be dumb, but could I have just ran it to build it and then have the, okay, whatever. CD debug, and then ray tracing.exe image.ppm. Okay. We run tolerance builds for speed. In that case, you would build it like this. Was there a source provided? Am I being dumb? Hold on, let me. What can open a ppm file? I need to Google ppm viewer. Awesome. Okay, that's what I got. That's what I got. Okay. Graphics hello world. If your image doesn't look like that, open the output and text file, see what it looks like. I guess I should install ppm viewer then instead of just having the one on right? Or do I have anything that can open it? Does VLC open it? VLC does not open it. That'd be too convenient. Oh, hold on. I can do it for VS Code. Is it safe? I don't know. I just installed the top one. Or, sure. Huh? I don't want to save it as a... Okay. So you're not an image viewer then? Restart required my... Okay. There we go. That's what I wanted. That's what I wanted. So then I can swap between the two, and this is what it looks like. Okay, that helps me so much. This sucks. I'm sorry, the one I installed sucks. Not okay. It probably doesn't suck. I'm just too confused to use it. I'll stick with that being the case. I'm just too confused to use it. Doesn't look like this. Double check your formatting code. Does look like this. Fails to render. You have a line difference. some reason report a problem. If it's greater, then you're pretty much done with the system. And ideation, everything that remains series uses simple mechanisms for generating images. You want to produce other images formats. Fan of image age, a header only image library. Let's add a proximity to our output. This anyway to track the progress of a long render, and it's also possible to identify a run that's stalled out due to an infinite loop. For outputs, the image is standard output stream, so leave that alone and instead write to the logging output stream. See log. Okay. So right under image height, standard C log slash scan lines remaining. I've already remaining. Why can I not type? Remaining. Yeah. Wrong arrows. Image height minus J standard, and then the flush makes sense just so it doesn't. Okay. You see running count of the number of scan lines. Sorry, this runs so fast you don't even see it. Don't worry, you'll have time in the future to watch a slow updating in progress. Okay. Technically, what we're supposed to do is, I think I can just do cmake dot dot. It didn't even end up. Yeah, conversion done generating run. Yeah, I guess I wouldn't even need to do anything like that. Okay, the vec3 class. Almost all graphic programs have some classes for storing geometric vectors and colors in many systems. These vectors are 4D, 3D position, plus some homogeneous coordinate for geometry, or RGB plus an alpha transparency component for colors. For our purpose, 3 coordinates suffice. We'll use the same class, vec3 for colors, locations, directions, offsets, whatever. Some people don't like this because it doesn't prevent you from doing something silly, like subtracting a position from a color. They have a good point, but we're going to always take the less code route when not obviously wrong. So for this, we do declare 2 aliases, vec3, .3, and color. Since these 2 types are just aliases for vec3, you will get warnings if you pass a color to a function expecting a .3, and nothing stops you from adding a .3 to a color, but it makes the code a little bit easier to read and understand. We define the vector class, top half of a new vec3h header file, and define a set of these vectors. I'm gonna get rid of these. Yes, move to recycling bin. You can, yeah, it needs to restart. I'm too lazy to do that right now. New file, vec3.h. Interesting that it's showing up as C when it should be. I don't know. I feel like the icons I use aren't the best right now, but that's whatever. Okay. Low key shit. I'm not gonna copy this, but this is long. I'm gonna copy this just because I don't feel like fucking writing all of that. Instantly right there. Okay. So class 3 vector public double E vec3. Float. Okay. Why can I not type right now? Double 3. My finger. Oh, does endif need a semicolon? No, it's just being weird, huh? Okay, that's weird. Don't know why it's doing that. And we can call back 3. Move my mouse. Fill it out like that. Then vec 3. Double E0. Double, forget it, E1. Double E2. E0, E1. E2. I'm assuming this is just the different constructors, right? I don't know. I'm being a bit dumb. My brain isn't really as active as I want it to be right now. Yes, thank you for cramping. Why is my hand cramping? I actually don't know why my hand's cramping. Const. Return E0 semicolon. And I'm just gonna copy this and then just change the values. XYZ. Okay, this is actually getting a lot to type, but I think we're like this is just making the class vector 3. So we're just making it so that we can actually have a vector, right? Is that what it is? Almost all graphics have for storing geometry and then menus. There's 4D, 3D position plus homogeneous coordinate for geometry or RGB plus alpha transparency. These 3 coordinates will suffice. Yeah, we're just making a class so that we can actually have a vector. Don't we? Isn't there only a vector? Am I being dumb? Don't like using it. Doesn't prefer doing something silly. Ah, fuck it. Okay, I guess we're doing this. I don't know. So just to save us some time, I'm just gonna read it, then paste it in. Operator. This is interesting. Dash const return negative. Oh, operator negative. Okay. Negative E, negative 1. Double operator and const return EI. And operator in I return EI. Because that's the pointer. So, low key, I need to refresh on pointers. And then vec3 add operator plus const vector plus. Okay, so this is vector subtraction and then vector addition. Is that what it is? E0 plus equals vector E. Yeah, I think that is what it is. And then we have vector multiplication after. Okay, so low-key I'm glad I'm not typing this out. This is hell to type out. And then vector division. Or matrix division. Vector, matrix, whatever you want to fucking call it. It's just same difference. Not really, but... No, that is... what am I waffling about? Matrix is just... multiple vector... Ah, fuck, I fucked that up. I feel like I waffle too much. No, that's what I was... that's what I was complaining about. Just an alias for vec3. Honestly, using point 3 equals vec3. So it's just using the same thing, but this way we can have more readability without having to comment. And then vector utility functions, standard O stream, operator, standard O stream add out, const vector 3 of v, vector 3 operator plus, vector 3 and u, const vector 3 and v. Okay, yeah, that's just doing the vector u plus vector v. And then minus, yeah, okay. And multiplication, t and b, Okay. Just to show, not that it really matters. It's just, I'm pretty sure it's literally just. Do we have scalar mults in this? Oh, where the fuck did it go? And then dot products here, and then cross product. Yeah, no, this is just. I don't know. Is there scalar though? Scalar multiplication, or is that just how? I can't remember. Is scalar multiplication just normal multiplication? No. Yeah, it's just the matrix. So it should be the same thing. Think so. I think it is the same thing. I'm just lazy, so I'm just gonna copy this. Mind you, this isn't the actual project. This is me just learning it by following their tutorial, and then I will try to do something. We use double here, but some use float. Double has greater precision range, but it's twice the size compared to float. Maybe important if you're programming limited memory conditions or hardware shaders. Either one is fine. Follow your own tastes. Using vec3, we'll create a new header file for color. Define a utility function that writes a single pixel's color to the standard output stream. Color H, vec3, color vec3, right color, standard out, cons, pixel color, auto R equals auto, pixel dot Y, B. Okay, fair enough. 0, 1 components because byte range 0, 255 and 255 R E byte. We write out the pixel color components out RGB. Again, I'm lazy, so I'm just gonna do. Yeah, sorry, this is written in the American way, not the Canadian color. They don't use it. They don't use a U. Unknown word. Interesting. I don't. It literally uses it right here. So I don't know why it says unknown word. Weird. We should remain to use both of these. Oh yeah, I low-key need more space for the IDE. This I'll just write myself. Color.h, and then hashtag include vec3.h. In main image width, and then for scan lines 4i. Oh, because then we don't need to do it ourselves, so it just replaces it. Okay, that's actually, that makes more sense. Wouldn't even have to do this. Auto. Pixel color. Equals color. Double I. Slash. If I can type image width -1. standard coat and pixel color. Oh, double semis, not singular. And then console log done. I don't know how long that wants it, but I don't know why it's like, it's probably not. It's probably just a few tabs, to be honest. You should get the exact same images as before. CMake dot dot. It's not really gonna replace it, but it should. Yeah, I don't know if it'll just replace it like that. Just have array class and a computation of a color seen along array. Let's think of array as a function. PT equals a plus tb, where p is the 3D position along a line in 3D. A is the array origin and b is the array direction. Array parameter t is a real number. Double the code. Plug in a different t and pt moves along the point. Add negative t values and you can go anywhere on the 3D line. For positive t, you only get the parts in front of A, and this is often called a half-liner array. You can represent the idea of array as a class, and represent the function pt as a function. I think this is copyrighted. Yeah, I think I didn't even notice. Let's just loop it, I guess. I want to play a different one though. Going back to it. It can represent the idea of array as a class. Where's the function pt? The function we call array at t. Okay. New file array.h. Again, I'm just gonna copy this, but make sure I know how it works. So for this public array cons point through origin. So that's just the origin vector, the direction vector, origin to direction, point 3 and origin cons, vector 3 cons, okay. It just returns, okay, so it's just what returns it. When we call origin, we call direction. That's a very simple way to run it, actually, instead of doing a getter function in Python. Interesting. So I can just do cons point 3 at and then origin. Okay, this is the actual thing, and cons return origin. Interesting. And then point 3 at double t cons return origin plus t times there. And t is what we're given initially, right? Point 3 origin vector 3, because these are private, and these get okay. Okay, interesting. At double T. Interesting, okay. Functions, array origin, and direction both return immutable reference to their members. Callers can either just use the reference directly or make a mutable copy. Yeah? Okay. Turn the corner and make a ray tracer. At its core, ray tracer sends rays through pixels and computes the color screen in the direction of the rays. Calculate the ray from the eye through the pixel. Determine which object the ray intersects and compute a color for those intersections. When first developing a ray tracer, I was too simple camera for getting the code up and running. I've often had trouble using square images for debugging because I transpose X and Y too often, so we use non-square images. What tone aspect ratio because it's width the same as height. Since we want a non-square image, we'll choose 16 by 9 because it's so common. It means the ratio of the image with the image height is 16 by 9. And then 60 by 9 with height 60 by 9, 1.778. For an image 800 by 400 has a 2.1, 2 to 1. The image aspect we can determine from the ratio of its width to its height. However, since we have given aspect ratio in mind, it's easier to set the image's width and the aspect ratio, and then using the calculate for its height. By changing the width image and it won't throw off our desired aspect ratio, we do have to make sure that we solve for the image height reducing. In addition to setting up the pixel, blah 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 blah. The rendered image we also set to need to set a mutually point through which the paths are seen. This is boring, I know. I'm sorry. Flashbang. This is in the main, so auto aspect ratio 16 by 9, image width 400, height ensure that it's at least 1. Image height, viewport widths less than 1 are okay, so they're real valued. Well, we don't use aspect ratio when computing viewport widths because the value set as the ideal ratio may not be the actual ratio between image and height. Well, then they would be finding the ratio with the actual ratio between the image and the image height compared. Okay, should I use the second webcam as a hand cam? Is that something I can do if I do this? Let's see. It's just straight at my balls, bro. What if I do it here? This sounds dumb, but like this is like a nose cam almost. This is just such a dumb idea. There's gotta be a better way to position it so it's not just looking at my crotch. But that's something I can put this on top of. Okay, so that's too high now. But then this is a button, so I don't know if that... I think kind of getting close to what I want to get for this angle. I know this is gonna look dumb for whoever's joining in, but this was not a well thought out or planned stream. So if I do this, oh, my hand's in the way if I do it there. What if I... That's not terrible, but yeah. As long as I don't put my hand here, it's not terrible to do that. Let me add that, but I guess smaller. Oh, I didn't realize how much my webcam technically blocks this screen. Maybe I'll put my webcam here. Does that work? I think. Low key? It does. Okay. I don't like how... I readjust my pants a lot. I don't like how you guys can see that, but it's whatever. Wondering why we don't start actually computing. Okay, we're good with that. Use an ideal ratio, which we approximate as best as possible with the integer-based ratio of image with over image height. Camera center point, point in 3D space from which all scene rays will originate. This is all coming referred to as the eye point. The vector from the camera center to the viewpoint center will be orthogonal to the viewpoint. I'll initially set the distance between the viewpoint of the camera center point to 1 unit distance off the focal length. Next, we will define the camera center, point in 3D space from which all scenes rays will originate. This will come referred to as eye point. Vector from the camera center to the viewport center will be orthogonal to the viewport. We'll initially set the distance between the viewport and the camera point to be 1 unit. The distance is often referred to as focal length. Okay. Why? Okay, I didn't realize my webcam is super dark. It is super dark. Maybe I should do color correction. Okay, I want to increase the gamma. Set that back to 0. Nope, that's not what I meant to do. Just gonna bring up. Ooh, don't bring up the brightness. Nope. I guess maybe I just need lights. Cause yeah, if I do any of that, it's just gonna get super bright. Oh, okay. I just upped the contrast. That's so much better. Let's do 1 point. Sure, whatever. That's an arbitrary number. But now you can see me. I didn't realize how dark I was this whole time. It looked like I was. That's a bit too bright now, but we'll leave it at that for now. It's not the. Oh, actually, I'm so bright. What? Because it looks fine, and then it. Like, I just saw a flashbang earlier, so yeah, now it's flashbanging me. Is it just when I'm not in focus? Is it like normal colors when it is normal colors when I'm looking at it? Okay, weird, whatever. For simplicity's sake, we'll start with camera at center. Also have the y-axis go up, the x-axis to the right. Yeah, y up, x to the right, and negatives pointing to the viewing direction. Refer to as right-handed coordinates. Alright, let me actually. I guess this would be if it was left-handed. This would be right. This is too fucking close. Like, thumb up. Like that, I guess. Okay, it's small, but I feel like. I don't have any filters on this. It's just small. I can make it like slightly bigger, but whatever. I'm not trying to chip it up too much. I kind of like it being like smaller, kind of, just so it's like a secondary thing. I will lower the brightness on this though. I feel like it's too bright. Configure video. Let me drop that down. Yeah, that's fine. Whatever. It's not the best, but this won't be as bright. Ooh, what if I do opacity? I'm getting distracted, I know, but okay, let me up the sharpness though, cause like low key, it's blurry. It's blurry as shit. Okay, I'm just gonna leave it at auto. I think the only way is if I video filters or effect filters. Does that look cool? That kind of looks cool. I think that looks cool. I don't know about you guys, but I think having that as like a low opacity thing there, I think that looks cool. Okay. We'll set the y-axis go up, x-axis to the right, and then negative z-axis. This is commonly referred to as right-handed coordinates. Now the inevitable tricky part. While our 3D space has the conventions above, the conflicts with our image coordinates, where we have to 0th pixel top left and then work our way down to the last pixel at the bottom right. This means our image coordinates y-axis inverted. Y increases going down the image. As we scan our image, we will start at the upper left pixel 0, 0, scan left to right across each row, then scan row by row, top to bottom, top navigate the pixel grid. Vector from the left edge to the right edge, and vector from the upper edge to the lower edge. Be inserted from the viewport edges by half the pixel to pixel distance. This way our viewport area is evenly divided into x height. Where our viewport grid looks like this. So this is that, and then this is the grid. So this is the delta, so the difference. VU, VV, delta U, delta V. This is Q. So origin. Is origin Q? I guess, whatever. What the fuck? Okay, I didn't know that was clickable. And then P00, viewport. In this figure, we have viewport grid is 7 by 5. Resolution is viewport upper left corner Q. Oh, upper left corner. Okay. Pixel 0, 0. Location, the viewport vector VU. The viewport vector VV. And the pixel delta vectors U and V. Drawing from all of this, here's the code that implements the camera. We'll stub in a function ray color const ray, then returns the color for a given scene ray, and which we will set to always return black for now. So we go back to main. I don't know, include if I can type without looking, ray.h. Then after IO stream, color ray underscore color const ray ampersand R. It's just the pointer. Not necessarily the pointer, but like fuck, I need to brush up on my pointers. But it does point to that. Fuck it. Sure. I just can't remember if that's the pointer or if that's the fucking memory address. Whatever. I'm being dumb. I haven't coded with C++ in forever, so I'm giving myself a free pass. Oh, so this is all getting changed. Fun. Okay, so the image is no longer just this. So auto aspect ratio, image width, so it's changing this. Calculate the image height, ensure that it's at least 1. And then now there's a camera with the focal length being 1.0, viewport height being 2.0, viewport width height times double image width length. So the image width divided by the height, and then multiply that by the viewport height, so we get the viewport width. Okay, fair enough. And then camera center equals 0.3000. Calculate the vectors across horizontal down the vector viewpoint edges. Auto viewport U, vec3 viewport width 0, 0. Viewport vec3 my negative height 0. Because U and then V. So we'd want it to go down the height, yeah. Calculate the horizontal and vertical delta vectors from pixel to pixel. Delta U is equal to the viewport divided by the width, and then delta V, yeah, fair enough, makes sense. Location of the upper left pixel, left camera center, minus focal length, minus viewport. Okay, interesting. So camera center is this, minus focal length, which is 1, but then minus viewport U divided by 2 minus viewport V divided by 2. Okay, and then pixel 100 location plus 0.5 times delta U delta V. So this replaces this. Just tab that. And then to render, instead of pixel color now, well, we keep right color, but then we add pixel center, which is equal to, oh, pixel 00, sorry. Pixel 00 location plus I times pixel delta U plus J. Okay, so that's actually doing that. Right direction equals pixel center minus camera center. Okay, no, that makes sense as well. Ray R, camera center, ray direction. Color, pixel color, ray color R. Okay. I think I get it. I didn't make ray direction a univector because I think not doing that makes for simpler and slightly faster code. Now we'll fill in the ray color ray function to implement a simple gradient. We'll linearly blend white and blue depending on the height of the y coordinate after scaling the ray direction to unit length. So -1 y greater than 1. Sorry. Y in between these values, whatever. Because we're looking at the y height after normalizing the vector. The gradient of the color in addition to the vertical gradient. I'll use a standard graphics trick to linear scale. When A equals 1.0, I want blue. When A equals 0, I want white. In between, I want a blend. This forms a linear blend or a linear interpolation. This is commonly referred to as LERP. Between two values, a LERP is always of the form blended value is equal to 1 minus A times the start value plus A times the end value. With A going from 0 to 1, putting all this together, we get vector 3 unit direction is equal to unit vector times, or unit vector of the ray direction. Auto A is equal to 0.5 times the unit direction plus 1. Turn 1 minus A times the color and A times plus the color, which is the end value. Const produces this. So let's see. Clear CMake. Do I have to delete this? Is that what I have to do? Nope, I do CMake and then I do this. I actually run it. I'm just being dumb. So we'll create a new file. I guess not. Let me try image to why did it do that? Huh? Why did it do that? CMake generated. Okay. Everything's saved. Min.cpp. Do I have to add all of them? I think so. Ray.h. vec3.h. color.h. Let's try again, because I think it didn't call upon those. Fucking mint. Is it, can I not just do a comma? No, but I feel like if it's included, it should just call it, no? Include, and that should build. But if I was doing GCC, I could just add them to the fucking... I'm confused. So I want to see this change to make sure I'm doing this right. can just do this. Do I have to do this? Ray tracing. Private. Don't do fucking like, I wish it wouldn't just do shit for me sometimes. $/ include. No, but it's not. It's just in the same fucking files as the main. I'm so fucking. Why would I want to do that? See, make current source directory. I guess. Would that work? Just do that. Oh, it's gonna do one of these, isn't it? Oh wait, that's actually maybe C make current source. And then / include. I guess I'll just move these into. No, but then I would have to call it like that in the normal file, right? Oh, that's gonna fucking suck to do. Oh no. I think I can just do this. If I can spell source right, that is. There we go. I just didn't feel like doing a separate folder. Took a fat minute. I'm sorry. Did I fuck something up? I swear I'm... Or... Okay, builds have been written there. So raytracing.exe works. Right? Yeah, and I can't. Okay, I can't. I know I can't do that. Well, I should be able to do this. Why? Okay, no. Okay, debug. then this. And it should generate a new file. And it should be the white to blue. No, it's the same fucking thing. Yes, I want to move those to recycling bin. I didn't get a blue and white gradient. I'm stuck with the original image. Why? Um... 0.5.7, 1.0. This should make it blue from what this is saying. Rendering blue to white gradient. I don't have that. Just gonna let it run. So it's done when it does it. So I have a fuck ton of files now. I'm so fucking confused. I'm actually so fucking confused. I'm so fucking confused. What am I supposed to be doing here? Like, genuinely, what am I supposed to be doing here? Okay. Oh, did I miss a negative somewhere? But I copy and pasted it. Like, I didn't... Because I knew I was going to mess up something. Change minus viewport to plus if V is already negative. That doesn't entirely make sense, but I'll try it. No, that doesn't make sense. That does not make sense. It has a unit vector. Okay. Division. It's the same fucking file. Am I tripping balls? It's just giving the same fucking... Am I just being dumb? I'm actually so confused. Okay, so it's giving me like a million fucking different answers, and I'm so fucking confused at this point. I'm just gonna fucking replace image the ppm. Do I have to like delete them every time I want to fucking generate them? I shouldn't have to. Okay, created a new one. Fucking text editor. P3. It shouldn't still be 256. 255. It shouldn't be 00. Okay. If I make this a fucking plus, save it. I didn't rebuild it because I'm fucking dumb. But if I do cmake, then run it, then go back to it. I don't feel like doing all that fucking. But I'm copying what he's doing. That's the fucking issue. I'm so confused. Unit direction. That's the fucking same. That's the fucking same. Okay? That's why I'm confused. The aspect ratio is updated. That's updated. Image height. Image width. That's all fucking correct. I'll go back to fucking minus, because clearly it's just pissing me off at this point. That's literally what I fucking have. Okay. Fucking. I guess we're doing this. CMake. Configure. Extract. I don't know if that fucking did it, but okay. CMake. This doesn't fucking exist. Awesome. Let's go do this. Did that work? Okay. So that should work. There we go. There we go. That's all. I didn't want to use AI, but fucking hell. Can't believe I got stuck on that. Finally. So a single object to our ray tracing, I'll use spheres and ray tracing. So it was just the way I was fucking building it. Do I have to do that every time? Or can I just run the CMake normally? Because I don't want to have to delete and then fucking rerun shit. Like, I should be able to just rebuild it. I'm hoping compile active file. Fine. Okay, that's whatever. That works. The object to reach these spheres. It's relatively simple. Equation for sphere radius r is the centered at the origin. Poor mathematical equation. I think I'll stop at 5 for now, because it is midnight. X squared, y squared, z squared, r squared. Yep. Saying is given a point x, y, z on the surface of the sphere equals r squared. You have to give it a point inside the sphere. Then is less than effect given outside the sphere, xyz is greater than r squared. If we allow the sphere center to be an arbitrary point, cx, cy, cz, then the equation becomes a lot less nice. In graphics, you always want performance to be in terms of vectors. XYZ stuff can be represented using vec3 class. You might note that vector from point pxy to center cxy is c minus p. Definition dot product c minus p dot product. Yeah, sure. It's just that, just not itself. Sure. Cx minus x squared plus cy minus y squared. Cz minus z squared, or cz minus z squared. Then we can rewrite this equation of the sphere in vector form as this. We can then read this as any point p that satisfies on the sphere. For array p at t, q plus td variates the sphere, and if it does hit the sphere, there's some t for which p satisfies the sphere equation. So we're looking for any t where this is true. C minus pt dot pc minus pt squared is going to be found replacing with pt with its expanded form. 3 vectors on the left, dotted by 3 vectors on the right, and if we solve this for the full dot product, we would get 9 vectors. Go through and write everything out, but we don't want to work that hard. If you remember, we want to solve for t, so we'll separate in terms based on whether there's a t or not. Now we throw out vector algebra to distribute the dot product. So minus td dot d minus 2d times this plus this dot that. Square the radius over to the left hand side. T dot d. It's hard to make out what exactly this equation is, but the vector is and r in this equation are all constant and known. Furthermore, the only vectors that we have are reduced to scalars by dot product. The only unknown is t. And we have t squared, which means the equation is quadratic. We can solve for quadratic equations ax squared plus bx plus c equals 0 by using the quadratic formula. Negative b plus or minus squared or b squared minus 4ac all over 2a. Canadian high school, my friend. So solving for t, was it high school? I learned in elementary school, I think. And the rate sphere intersection equation gives us these values for a, b, and c. A equals d dot d, b minus 2dd, c equals this. I'm assuming that's how we're gonna have to write it in here. As you know, above, you can solve for t, but there's a square root part that can be either positive, meaning 2 real solutions, negative, meaning no real solutions, or 0, meaning 1 real solution. Algebra almost always relates very directly to the geometry we have is 0 roots, 1 root, 2 roots. Creating our first ray traced image. If we take that math and hard code it into our program, we can test our code by placing a small sphere at -1 on the z-axis and then coloring red any pixel that intersects it. So this is, I guess this is it hitting the plane we have, because we are in a 2D space, right? And now we're just adding onto the z-axis. They're adding this into main above ray color. So boolean hit sphere, so it's just gonna be if checking if it's colliding with what we have. Point. I could just copy and paste this, but I actually want to type this one out. Center double radius const ray at wrong one ray at r like 3 origin center, I'm assuming center minus r dot origin. Awesome. And auto a. This is for the quadratic formula. Dot product of r dot direction, comma r dot direction. Oh yeah, because it would just be the same thing again. Because that's that. So radius dot direction, or not radius, ray dot direction, not radius, solo. auto b equals negative 2.0. I don't always have it up, so I'm just gonna keep scrolling up when I want to compare it. So minus 2d times c minus q, or not times, a dot product c minus q, so it'd be, and then dot c q, right? I hope so. I'm getting tired. Mind you, the battery's low on this. It says it's charging, but I guess it's not charging too well. If that goes out, I'll just swap webcams and then whatever. But I should be good. I'm almost on 2 hours of streaming. Let me not be stupid right now. Let's multiply the dot product, the r dot direction, comma, OC, and then I'm just gonna copy the rest of it. I already know what it is. Auto C is this. It's the dot product of OC and OC minus the radius. Minus the radius. Yeah, this is OC. The origin center? Question mark? I'm forgetting already. Yeah. And then discriminant is b times b minus 4ac. Yeah, that's just, that was just always there. Pointer to a bound function may be called to the function. Did I fuck that up? Equals dot. No, I just forgot to do that. And then we return the discriminant if it's greater than or equal to 0, which is the true or false. What is that? You have to hit the sphere. And then this is just showing if it hit sphere 0.3 0 comma 0 comma minus 1 comma 0.5 comma r return color 1 comma 0 comma 0, which is just red. Okay. I cannot just do make, but can I do cmake dot dot without having to re-fucking build everything? It says done. It did not fucking. Okay. Am I just missing, like... Okay. Am I... I'm a bit confuzzled now. I'm just gonna search up the commands, bro. Okay. So that should have rebuilt it, and then I should be able to run this. Just because it's open. I don't have to fucking keep CDing into the... Okay, you know what? I'm gonna make a new one, and I'm gonna see this into build, and CD into debug, and then just run it there. There. I'm gonna have the 2 fucking terminals. There. That's a million times easier. Have one be for fucking rebuilding it, and then have it, cause like, fucking hell. Technically, I could just have the fucking thing always in it, but yeah. Like shading reflections rays in more than one object. We're closer halfway done than we are at our start. One thing to be aware of is that we are testing to see if rays intersect with the sphere by solving the quadratic equation and seeing if a solution exists, but solutions with negative values of t work just fine. If you change your sphere center to z equals +1, you'll get exactly the same picture because the solution doesn't distinguish between objects in front of the camera and objects behind the camera. This is not a feature. We'll fix those next. Okay. Let me put this back up here. Should I keep continuing for this one? Shading with normal surface. Is a lot. Yeah, I'm gonna pause here for now. We'll continue this in a bit maybe, or maybe I'll continue this as a video instead. I don't know, but it's been 2 hours, so I'll see you guys later. And also, I feel like the camera's gonna die.